Hi everybody, and welcome to another CS0 Intro to Java Programming video. In this video, I'm going to talk about creating inner classes, I'm going to talk about constants, and I'm also going to talk about this method called pack. This is a big video, and I can't stress its importance enough. This is going to be our first foray into writing classes and instantiating them in another class. Sort of. An inner class is a class that we define within the scope of another class. It's going to be outside of methods, but it's defined in the class. It allows us to do things like override a JPanel and use the JPanel's graphics context and paint component method. Well, why is this important? Well, you've seen problems in the past when we use the JFrames paint component. When we use the JFrames paint component, or paint method, the graphics context stretches from edge of frame to edge of frame. And the edge of frame actually goes underneath those little boundaries or borders around the JFrame on the top and bottom left and right. And if we put GUI components down in the frame on its content pane, those GUI components are laid down over the top of the graphics context and overlap them. So the graphics context actually goes underneath the GUI components, and you can actually accidentally draw underneath those GUI components, which is also kind of a problem. Well, if we limit our drawing to the graphics context of a JPanel, we can put that panel anywhere we want within the frame, and it'll only draw within that panel. It's pretty cool. Let me show you this class really quickly and what it looks like when we run it. And I have my JPanel right here. And its graphics context stretches from edge of panel to edge of panel, but it doesn't go underneath the frame. I have this oval drawn at 0, 0 on my panel. You remember when we drew an oval at 0, 0 directly to a frame? The top of the oval would be going off of the top edge, the left of the oval would be going off the left edge. We had to do some offsets and a little bit of fudging with pixels. It was messy. I didn't like it. Well, if we draw to the graphics context of a JPanel, that JPanel is going to be fully contained within the viewable area of the frame, and therefore when we draw to the panel, it'll draw fully within that frame and nothing will overlap it. Furthermore, if I draw on the bottom edge here, the height of the panel, it's going to go right to the edge of the panel and not get overlapped by my GUI components, which would have been a problem on a JFrame. Okay, so that's why we override JPanel. The other reason we override JPanel is you might have seen that we had some problems in the past of whenever you get the graphics from the frame and you draw to it, you don't have the ability to refresh that graphics context. In other words, wipe everything off the graphics context and draw something fresh. It would always just draw over what was previously there. So in the last set of videos, in the last unit, we came up with a little workaround, a hack, if you will. We drew a full-size white rectangle and then drew on that white rectangle, and that white rectangle would just cover up all graphics from previous draws. Well, we don't need to do that anymore. We have the ability of doing something called repainting the graphics context of the JPanel, and it wipes out everything that was on there previously and draws it completely anew. Right, let's get into the code. For starters, I have a couple of constants, and I use constants in my program to substitute any hard-coded values. I especially use constants when I have things that I want to be consistent throughout the whole program. For example, what if I want to set the size of the frame and the size of the panel relative to one another? Well, what I could do is I could make a constant called frame width and frame height, and I use that to set the size of the frame. Okay, so I've got these two constants, frame width, frame height. And you might notice that the naming convention looks a little different than what we've done in the past. Normally with variables, it's lowercase leading, camel case thereafter. So GUI panel would be lowercase GUI, capital P, lowercase ANEL. Well, with constants, the common convention is to make them all uppercase and have words separated by underscores. We've seen that before with exit on close. We've seen that with south and center, north, east, west. Okay? Well, I'm just sticking to that naming convention for constants. A constant is a variable whose value, once it's been initialized, cannot be changed. This makes your program stable. It makes it so that if you've got some value that you know you want to be consistent throughout the whole program and you want a lot of things in the program based on that value, you make it final, and that's going to make it so you can't change it. So final is what makes it constant. So I cannot reassign frame width or frame height. They are forever that value. Okay, so I've got some other instance variables, a JPanel, a display panel. This is new, and we'll take a look at where that came from in a little bit. A JButton and a color. Let's look at the main. I have my instantiating my InnerClass basics object, calling it frame like I always do. I'm setting the size. I'm setting the default close operations. I'm setting the layout to border. This was new in the last video. If you didn't watch the border layout video, you need to go back and watch that now so that you understand how border layout works. And you can see that in my dimension for the frame size, I'm setting it to frame width and frame height. And right now, actually, that's kind of irrelevant. If we look at this one, it looks like my JPanel is 400 by 400, and then my component down here, my panel down here, is just high enough for my button, and the frame is just 400 high by that. Well, the height that I set was 600. That seems weird. The frame doesn't seem to be responding to making the panel or making the frame bigger. And I'll get into why that is in just a little bit, but keep that in mind. Notice that the frame width and frame height is not responding to this right now. All right, so I set it to border layout, setup GUI, pack, set visible true. Let's take a look at setup GUI really quickly. So I'm getting my content pane, and then display gets new display panel. Now that I'm actually constructing or instantiating my display panel thing, let's take a look at where that comes from. This is not a class from Java. This is not something that comes from AWT or Swing or any of the other libraries that we're familiar with. This is something that I wrote. I wrote a class called display panel, and I'm instantiating. Much like we've done in the past with our main class, we instantiate our main class within its own main. Well, now I'm instantiating an inner class in the setup GUI method. So this comes from an inner class. Let's look at that inner class. So if we look at the scope of this class, my class definition starts right here, and it ends way down here. My inner class starts right here. Class display panel extends JPanel. And the scope of that goes from here. It includes this thing called a constructor, its paint component, and then it ends here. And then this is the end of my main class. Okay, so you can see that my display panel is outside of any other methods. It's not in action performed. It's not in setup GUI. It's not in main. But it is in the class definition. So an inner class is nested inside of a class, but is outside of all methods. And all it is the definition of a class. So I define a JFrame class every time I make a program so far, right? So this is extending a class, and a class is going to be a collection of data and methods that are going to make something happen. Well, an inner class is the same thing. It is a collection of methods and data that will also do something. This display panel here extends JPanel. So what I'm doing here is I'm making a class that is a JPanel. It has all those JPanel-like qualities. It's got its own content pane. It's got its own graphics context. It can have layout managers. It can be added to a frame. It does all those things that JPanels do that we've seen in previous videos. But we're going to add special things to it. This is going to be a special JPanel called display panel. And the display panel is going to have a preferred size, a background color, and it's going to have a paint component. The paint component comes from JPanel class. And we are doing something called overriding it. In other words, we are rewriting the paint component to behave differently than the paint component from the JPanel class. We've been doing this all along with paint, right? We've been overriding the paint method in our JFrames. I don't have it in this one because I'm not using JFrames paint, but in previous examples and previous videos, you saw us overriding paint. And when we do that, we always make a call to super paint so that it works correctly. And what that's doing is it's replacing the paint method from the JFrame class and extending on its current capabilities and making it do things slightly differently. In this case, I'm overriding the paint component, which is very similar to the paint method in the JFrame. So the first thing we have to do is we have to call to the super paint component method, pass the graphics G object into it, just like we would do in paint. And otherwise, paint component works exactly the same. You can set colors to the graphics context, and you can draw ovals, and you can draw whatever you want. And we'll see in future videos that we can do all the same things that we would do normally in a paint method. Okay? So this is my nested inner class. I've got my class header. I've got something called a constructor, and this is invoked as soon as the object is instantiated from the class. And what I'm doing in the constructor is I'm setting the preferred size. Now, set preferred size is going to set up the default size of that panel. It's going to define how big it's going to be when the panel is drawn. Now, if I grow the frame or shrink the frame, the panel will also extend as well to be the size of the area that it's been added to. But this is going to be the default size. And what I did is I set it based on my constants. It's going to be the width of the frame and 200 less than the height of the frame. Okay? So frame width, frame height, I set to 400 and 600 respectively. And so the preferred size is going to be 400 by 400 because I'm subtracting 200 from the 600. I'm setting the background color of the JPanel to white. And I could set that to any color I want, but you can see that the only part of the application that's white is the JPanel's background. All right, so we've seen how that the frame width and frame height will set the preferred size of that panel. Let's talk about how that panel actually interacts with the frame now. I have instantiated it to the frame, and I want to go back up to main for a second before I get into the rest of the GUI stuff, because we've got this method that I introduced called pack. What pack does is it sets the size of the frame to be exactly the size of the total number of components that are in it. So it'll give the components just enough room to exist, but it won't be any extra and it won't be too small. If I don't use pack, the frame could be too small for all the components. It could be too large for the components, and we have to kind of push the pixels bigger and smaller of the frame to make sure it fits things nicely. Well, pack does this all for us. It's always going to make the frame just the right size for the components that you put into it. So you remember when I said that the dimensions here, when I set the size on the frame, don't really affect it. So if I make, let's say I make the frame width 1000, the frame isn't actually going to be 1000 wide. It's going to stay that 400 width because it's been packed. So the frame shrinks down to be just the size of the panel. Now, if I set the panel width to 1000, you'll see the whole thing gets wider. See, this is 1000 pixels wide because I used that constant, the frame width constant, to set the size of the panel, the preferred size of the panel. So the panel now stretches wider, and the frame gets wider because it always makes enough room for its components. If I take pack off, I'm going to set this back to 400. If I take pack off, and I go back to frame width here, comment out pack, you're going to see now that the frame is responding to the frame height and frame width size when I set size. You can see that the frame is now 600 high by 400 wide. And if I make it 600 wide by 600 wide, it's going to expand as well. Okay, so that's what pack does. Pack allows you to make sure that the frame will only be as big as its components, and we don't have to worry about setting the frame size. So I'm going to undo pack, or I'm going to undo the comment on pack, and you'll see now it will always be just the size of the panel itself, and it's not going to worry about whatever size we set to the frame. Okay, so it's no longer 600 high, it's 400 high. Go back to 400 width here. So that's pack. Makes the frame collapse to the size of its components. Let's get back to the GUI. So I instantiate my display panel here, and that's going to set up the paint component method in the JPanel. I'm creating a JPanel for GUI panel, which is just going to have a flow layout to it. I'm going to change the color, or I'm going to create a button called Change Color, which will, when I press it, change the color of the oval. I'm going to add the action listener to the Change Color button, and I'm going to add the GUI panel I'm going to add the button to the GUI panel, then add the GUI panel to the frame. I'm adding the GUI panel to the south and the display panel to the center. All right? So that's all the stuff that we've talked about in a previous video on border layout. This is not new stuff. If you don't understand the way border layout works, go back and watch that video. All right, now we made this thing interactive. Like I said, I made this thing an action listener, and we've got a button with an action listener on it. I've got a button called Change Color, and I've got a color called C. Here's how this thing becomes interactive. Let's look at action performed. Action performed is going to have 3 local variables, an R, a G, and a B that'll be 0 to 255 inclusive. So those are going to set up our color values. We've done this in previous videos, so I'm not going to explain this logic again. So what it's going to do is it's going to set those values to a new color and hold it in C, and then it's going to repaint my display. Repaint forces a call to the paint component method of my display panel. Because I'm doing display.repaint, that means the display object, which comes from the display panel class, is going to get its paint method invoked. When I invoke the paint method, it's going to set the color of the graphics context to whatever is held in C. So when I do action performed, it's going to create a new color in C. It's not going to be the same color as the previous color, and then it's going to repaint that graphics context with that new color in mind. Okay? So what happens is it calls this, and the new color is used to draw my oval. All right? So that's how I use the paint component, that's how I use repaint, and that's how I make that display panel JPanel interactive. All right, to review, we worked with nested inner classes that had a constructor and had their own paint method. And we instantiated those and added them to a JFrame so that the paint component of that panel only takes up a finite area of the JFrame, not the whole JFrame. We also talked about using constants and the pack method. Now, when I said that this is an important video and this is an important class, I really meant it, because I'm going to use this structure basically in all future videos until we get on to true object-oriented programming. So really make sure you know how this class is structured, really make sure you know how things are put together. I recommend playing around with this class a little bit, changing values, adding other things in there, see if you can add some other variables and have them update and action performed such that it'll make the circle bigger or smaller, change something else, maybe have it draw a few squares or something like that. Do some things to this program to make it behave differently until you fully understand its structure. Thanks for watching.